This is R.D. Sharma Solution, Class 12, Chapter 18, Maxima and Minima. Exercise is 18.5. A straight line is drawn through a given point. This P1, 4 determine the least value of the sum of the intercepts on the coordinate axis. Now, if you understand this diagram, it will be very easy for you to solve this question. So, we are making the coordinate axis. This is your x, this is your y. And the question is asking that a straight line is being drawn from 1, 4. So x is 1 and y is 4. So roughly we are trying to draw a line, and that line is going to cut or intersect the x and y axis. The length of the x axis from 0, 0 till where it cuts is x intercept. Similar, from 0, 0 till it cuts the y axis, the distance is y intercept. So the question is all around this x-intercept and y-intercept. Now this is a line which is passing through 1, 4. We are going to make an equation of a line passing through 1, 4. What is the line of the straight line equation? Y minus y1 equals to mx minus x1. Line is passing through x1, y1 having a slope m. What is x1, y1? We already have it. x1 is 1 and this y1 is 4. From where did we get it? It's already given in the question. So we are putting it in the equation. So y1 is 4 and x1 is 1. X-intercept, this is basically a distance, from 0, 0 to, we know that on x-axis y is 0, on y-axis x is 0. So I am just placing 0 wherever it will be, and the next thing will be, for y-intercept x has to be kept 0, and for x-intercept y has to be equated to 0. So that's what we are doing right now. Y is equal to 0. So this is negative 4 equals mx minus 1. Just put y equals to 0. So you have a relationship of x and m. Call it as certain number of equation, means give it a number. Next thing is x equals to 0, because now x equals to 0, we are trying to find out the y-intercept. Now this content is actually placed there. I'm not writing it because of the lack of the space, but this whatever is coming here, it is they are basically the coordinates of x and y. Y will be equal to what value in terms of m? We have placed x equals to 0, that is we are talking about the y-intercept. X-intercept is m minus 4 by m, that we already got. Okay, y-intercept is also this one, negative m plus 4. Just imagine that where I'm pointing, it is being placed there. Now the intercept is already with us. Next part of the question is, determine the least value of the sum of the intercepts on the coordinate axis. So this is x-intercept, this is y-intercept. So the question is all about the addition of the x-intercept and the y-intercept. So let us call it as S. X plus y, these both are intercept. And the values are known to us. One is m minus 4 by m. The other one is a negative m plus 4, or you can call it as 4 minus m. Now, this is S. Now, the third one, we need to also establish that it is least. For that, we need to differentiate. I am differentiating it right now. And when we differentiate it, because actually what differentiation of what content? Addition of x-intercept and y-intercept. So, when we differentiate this, you have m minus 4 by m plus 4 minus m, or m minus m plus 4. So when we differentiate this, m by m can be 1, 4 by m minus 4 minus m plus 4. So just differentiate it, and you know already that differentiation is. I have not differentiated it yet. It is actually s. I'm just saying that you need to differentiate it now. Once you differentiate it, you are going to get certain equation or an expression. So when you get this expression, this is 4 by m square and minus 1. The next thing will be ds by dm should be equal to 0. ds by dm equals to 0 means 4 by m square equals to 0. 4 by m square minus 1 equals to 0. 4 by m square equals to 1. M square is equal to 4. M is equal to plus minus 2. M is plus minus 2. Now you tell me whether we can take 2 or negative 2. We have to check for both of them. The fifth thing is we need least, and we'll check for the least. For that, we need to double differentiate. So 4 by m square minus m 1 was the first differentiation. You need to differentiate 4 by m square minus 1 again. It is minus 8 by m cube, and this is the double differentiation value. First you have to check for m equals to 2, then we will check it for m equals to negative 2. And we will try to take only that value, or we will definitely take that value which gives us positive. Positive means least, negative means maximum. When you place this, what do you get? You have this as a negative 1, this is less than 0, this is your maxima. When you have this minus 2 whole cube, you will get minus 8, negative negative cancel, you will get a plus. So this plus is greater than 0. Minimum it is. So you get maximum and minimum. What are you going to use? Least means maximum you have to take. So for that, you have to take the plus 2. M equals to negative, it's going to be one value which has given us the maximum value. For that you can take 2. Okay. This value has to be placed here. In this equation, we have to put this negative 2. Because for negative 2, we have got this greater than 0, which is minimum, right? So that's why negative 2 is what is to be placed in the original equation. And this equation gives you 9. So what is the answer? This is 9. So this is, I placed it in S actually. So just try to go along with the diagram. Once the diagram is clear to you, all the things you have been doing since the first question of this exercise. Total page of area 150, the combined width of margin at the top and the bottom is 3 cm and 2 cm. What must be the dimensions of the page in order that the area of the printed matter may be maximum? Alright, you have a page not like this, but just imagine that this is a page, A4 page. The first thing we are going to do is we will take x as the length, y as the breadth. X length, y breadth. So this is the x length and this one is y, which is breadth. You can take any of it. You can take x also in the place of y. It's up to you. And now I'm making an area where actually the content will be written or printed. So the other part will be only blank. This is the printed area. And what is the top? Top total margin is 3. So this is x. Just call it as, because there will be margin on both the sides, top and bottom also. So x, you have to subtract 3 so that you get the actual printed space. X minus 3. And what about the 2? That is this one. Call it as R and S. I'm just saying it because you understand what I'm trying to do. R plus S is 2. P plus Q is 3. So you have to subtract this 2 from y. Y minus 2. So x minus 3 into y minus 2. But before that, we already have total area of the page. So x into y, we already have it. And this is already given as 150 in the question. The total area. We can get certain relationship between x and y. You can call it as y equals to 150 by x or x equals to 150 by x. We are very good and very well versed with x. So we always take x on the right. So that when we differentiate, we only get x. What about area of that space where printed content is going to be printed? Means the area which is actually of any use. Other part will be blank, which we call it as margin. So the area is length into breadth. Now the area becomes x minus 3 into y minus 2. Multiply them. And when you multiply them, you see x into y is what? From equation number 1. No, from equation number an equation which is higher than or written above equation number 1, x into y is 150. So in place of x into y, just write 150 minus 2x minus 3 into this 150 by x, and this is plus 6. This is your area. Just differentiate it now. dA by dx is what you need to perform. The constants are going to be 0. Minus 2x is negative 2. And this 3 into 150 is 450. This is going to be 1 by x differentiation is negative 1 by x square. Next one will be what? You have to equate it to 0. So this is going to be 0. Negative 2 plus 450 by x square is equal to 0. So you get 450 by x square equals to 2. X square is going to be equal to 450 by 2, that is 225. So x square is 225 here. So 2x square is 450. That's what. And you know already the under root of 225 is 15. So that's what we are going to get it now. X square is 225. So x will be equal to plus minus 15. Now tell me, are you going to take a negative value? No. We can't. The distance cannot be, or the length cannot be negative. So we are definitely going to go with x equals to 15. How about y? Y is 150 by x. 150 by x is 150 by 15, which is going to be 10. So you already got the answer. This is the answer. X is 15, y is 10. Now you have to show one more part, which is the maximum part. So once you go along with this, you have to differentiate it. I'm double differentiating it right now. When you double differentiate it, this negative 2 will be 0. 450 by x square, so you just have to differentiate 450 by x square goes up, x to the power minus 2. You will get this differentiation as negative 900 divided by x cube. You put x equals to 15, that is going to be x value, because we have just discarded x equals to negative 15. So you don't worry about the number, you worry about the sign. When it is less than 0, you are definitely going to get the maximum. So maximum you are going to. What is the maximum at x equals to 15, y equals to 10? This is your answer. And if you do it or perform it using the diagram, solve it using the complete diagram, margin also shown, it will be easier for you. The space S is described in time t by a particle moving in a straight line is given by this one. Find the minimum value of the acceleration. Now this question is related to an earlier question which I told you that the equation being given, just don't go about differentiation and double differentiation. You have to come up to the question. The question is saying acceleration. S is distance, ds by dt is velocity, d2s by dt is acceleration. So we have to find the minimum value of the acceleration, not the s, not the distance, not the space. I hope you got the idea. So you have to double differentiate it, then a will come and then you have to start the question. That will be the beginning of the question. What I am trying to suggest here is s is equal to t raised 5 minus 40t cube plus 30t square plus 80t minus 250. ds by dt is your velocity. The differentiation is quite clear to you. You already know it. It's 5t raised 4 minus 120t square plus 60t plus 80. Why did we get this? Alright. Now this ds by dt, this is velocity. Still we haven't reached the start of the question because the acceleration is d2s by dt square, which is dv by dt, which is the acceleration. Acceleration is the rate of change of velocity and velocity is the rate of change of distance. We have 20t cube minus 240t plus 60 is the differentiation. Here the question will start. Don't worry about the two equation in the when we wrote the two equation in the first and second line. Third equation is the actual thing. So now you will differentiate this one. dA by dt is the actual differentiation. And this is what we are going to equate it to 0. 60t square minus 240 equals to 0. 6 4s are 24. You know that you are going to get 4t square equals to 4. So t will be equal to plus minus 2. Can the time be negative? Never. Until you go to some, time stamp or some technology which takes you earlier. So t is plus 2, now we are going to double differentiate it in order to show that it is the minimum value. d2a by dt square is a differentiation of this one. 60t square minus 240, you got 120t. So when t is equal to 2, it's 240, 240 is greater than 0, you are going to get minimum. It's minimum, alright. In order to get the minimum value, where do you put? First equation, second equation. Tell me. Yes, in the third equation, because the acceleration is actually 20t cube minus 240t plus 60. This equation, call it as equation number 1 because this is the actual equation from where you need to start. So t equals to 2 is 220 into 2 cube minus 240 into 2 plus 60. And this gives you acceleration as, acceleration can be negative positive, right? So the car is going to be slower and faster with respect to the acceleration. So you get a negative here. So that gives you the acceleration value. So first differentiation of the original equation, second differentiation of the original equation, then you come to the third equation and that is from where you have to start. So whatever we discuss is in front of you and this is the written material which you need to follow. Alright. Now there is a good news for you. The good news is these are 46 questions. But they are very strong questions. Every question needed a lot of effort and every question, if you have understood, I think that this chapter is clear to you. And so this is the last question. This is the good thing for you. And if you understood all these 46 questions, this chapter will be very easier for you in your later coming exams. And you will be saying, don't talk about here and there, tell us how this question is going to be solved. So let us get back to the business now. Distance at a time t is given as like this. This is distance. Find when the velocity is maximum and acceleration is minimum. Don't worry about minimum and maximum. First worry about the velocity and acceleration. Since s is the distance, ds by dt or ds by dt is velocity and d2s by dt square is acceleration. So the differentiation of the distance is velocity. We are going to take this original equation, which is t raised 4 by 4 minus 2t cube plus 4t square minus 4. So velocity is ds by dt. This is velocity. What is the differentiation? It's quite clear to you. It's a very simple equation. The logic of this solution may be important to you, but the differentiation, if you already completed differentiation chapter, it will be easier for you. So I've now differentiated the distance, which is the velocity. Let us find out the acceleration also. Just differentiate the earlier equation. So I'm differentiating t cube minus 6t square plus 8t. You get t 3t square minus 12t plus 8. First, we have to check for the velocity. So velocity and acceleration will be dealt separately. dv by dt has to be equal to 0. Then you will get the critical point. Again, dA by dt has to be done. But let us only concentrate on dv by dt. This t3 square minus 12t plus 8 equals to 0. This is not an easy equation. You will not be able to solve it. You have to use the Sridharacharya formula. I'll leave it to you because you know that minus b plus minus under root b square minus 4ac by 2a is what will give you 2 roots. If you are not able to make the factors, because it is not possible in here, so you have to use this Sridharacharya formula. Let me tell you the final values which are going to come. So it will be 2 plus minus 2 by under root 3. Here a is 3, b is negative 12 and c is 8. Use all of this. Now d2v by dt square double differentiation we have to do. What is the double differentiation? 3t square minus 12t plus 8. And this is the double differentiation of the, basically the differentiation of dv by dt has to be done d2 by v by dt, which is actually the acceleration. But don't worry about this, because here you are going to put 2 plus minus 2 by root 3. And you have to place both the values, 2 plus minus, both plus minus has to be kept in this d2v by dt square in order to get the negative and positive, so that you can reclaim or claim that you are going to get the minimum or maximum velocity. You are going to get maximum velocity for sure. For 2, please remember both of these. I am just showing you for what value you are going to get maximum, but the other value has also to be placed here. d2v by dt square is 6 into t, 2 minus 2. As I said, 2 plus 2 by root 3 also has to be kept. But I am just showing you 2 minus 2 by root 3. You are going to get a negative. Negative means less than 0. Less than 0 means you are going to get a maximum value. All done. Velocity thing done. What will be the velocity? Velocity is, you have to place this value minus 2 by root 3 in the velocity equation, which is the equation number 2 here. Acceleration is what? You will start with the acceleration now. Acceleration, you have to differentiate. Velocity is done now. We have come to the second part of the question, which is acceleration. Differentiate it now, dA by dt. Once you differentiate, you will get 3t, 6t minus 12. You already got it in the second part. But you have to do it again, all over again. Just equal to 0, t equals to 2. So when you have t equals to 2, you have to place it in the acceleration equation. When you place this in the, because once you double differentiate, you are going to get 6, and which shows you definitely that it's minimum. Greater than 0 is plus means minimum. So at t equals to 2, you get this one. At t equals to 2 minus 2 by under root 3, you are going to get the velocity. So there are two values for which you get velocity and acceleration as maximum and minimum. And you can refer here also what we have done just now. All these things have been explained, but 2 plus 2 by root 3 and 2 minus 2 by root 3 both needs to be checked. I just told you 2 minus 2 by root 3. That is just for my saving of time. But you have to, you have to do it, all of it. So all of this has been done. Thank you so much. Have a good one.